Okay, for question D, for what value of t is the particle moving in the negative direction? Okay, well the way I interpret that is to mean this: when is velocity negative? Okay, now we already know, okay, based on some of the derivative from part B, that velocity is equal to 3t squared minus 3t minus 6. So what I'm interested in is where this is less than 0. So this is taking us back to Math 20 work. Okay, this is what you did in Math 20, and then you did a little bit more of it in Math 30. Okay, so to solve this right here, what I need to do is factor it first of all. Okay, so first of all, I can take out the common 3. So t squared minus t minus 2 is less than 0. And then when I factor this, I get t minus 2, 3 times t minus 2, t plus 1 is less than 0. And what that tells me here is, when I take a look at my velocity, okay, function, what I want to do here is make sure that I utilize information that I have in the past. I know that that's a quadratic, okay? I can see it, it's a square term. I know that it's a positive quadratic, so it's going to open up. I know, based on my work, that it's going to have an x-intercept of -1 and an x-intercept of +2. Now, the original function, though, is only defined where t is greater than or equal to 0. So what happens here is the 0 point becomes important, because this isn't defined for negative time. So when is this thing moving in a negative direction? Well, it turns out right at the very beginning, it is already moving in a negative direction. Okay, at time equals 0, it has in fact, at time equals 0, it has a velocity of -6. So when is it moving in a negative direction? Whenever the t value is an element of the half-closed interval starting at 0 and ending at 2, but not including 2, because at 2 the velocity is in fact 0. But at 0 the velocity is -6, so you would include it.